All right, so now for the next compound on deck, we'll be talking about the number of chiral centers and stereoisomers that can be derived from what? D-ribose. This was a full exam question. They said I state the number of chiral centers and what stereoisomers that can be derived from D-ribose. So D-ribose, you could say this is D-ribose, and okay, ribose. Okay, this is actually the ribose that they're talking about, right? So if they ask you to state the number of centers that can be, I've showed you guys how to calculate chiral centers over and over, but let's go again. So take it that there's a C here, which is the first C. So this whole thing is actually what? One compound. So what is a chiral center? Chiral center is a carbon that has what? Four different things binding to it. So if you add this one to this C, which is the second C, all right, plus another thing joining here, that means this C is actually a chiral center. It has four different things binding to it. Okay, the next one is this C. If you now take this whole compound as the same thing, you add to this C, it still makes it a chiral center. Now if you now make this whole compound as one, you now add it to this C here, it now makes it as what? A chiral center, right? So that means you have chiral centers at what? The second C, the third C, and the fourth C. All right, so let's see how we can be able to put this in an exam situation. In an exam situation, you answer that, okay, D-ribose actually has what? 5 carbon sugars. All right, you acknowledge that it's actually a pentose sugar, right? So that means it has 3 chiral centers at what? Position 2, position 3, position 4. So each chiral center can have what? 2 different configurations, either the R or S. That one is not really needed in your answer. So now you now proceed to what? Calculating the stereoisomers. So the stereoisomers you now say is there are 8. There are a total of 8. It's a very simple question. I think it was only 1 mark allocated to it. But for further reading's sake, these are the stereoisomers. Alright. So let me just list them. Like the 8 stereoisomers, these are their names. We have D-ribose, we have L-ribose, we have D-arabinose, we have L-arabinose, we have D-xylose, we have L-xylose, we have D-altrose, and we have L-altrose. Okay, so this one is just for further reading sake, in case you see their name anywhere, because these things are actually what? Applied in pharmacology, making drugs. So if you see them somewhere, you just simply know that what? They are actually what? Stereoisomers of D-ribose. Alright, so that's it.